Welcome to Mr. Beck Does Your Homework. This is physics homework number 4. This is the introduction to this homework. This homework is all about position time and velocity time graphs. So some of the things you need to know are that time is always on the x-axis and position is always on the y-axis, which is funny because we use the variable x for displacement sometimes. So x is there and t is there. As I have a graph, if it's going up this way, this is a constant velocity. And then if I'm moving over here, that would be zero velocity. And if I'm moving this way, that would be a negative velocity. Here I've got a positive slope, so positive velocity, zero slope, zero velocity, negative slope, negative velocity. What I know is that the slope of the position time graph, xt graph, is the velocity. It is the velocity. So if it's positive, it'll be positive. If it's negative, it'll be negative. The average velocity is going to be my total displacement over total time. So if I want my average velocity from the beginning to end of time, what I'm really looking at is my initial position and my final position. So I really would only want my change in position was going to, in this case, would be a very small amount over all of that time, which also winds up to be the slope of the line connecting those 2 points. If I wanted my average velocity between this point and this point, it would be the slope of this line, because it would be my total displacement in that total amount of time. So you can't just find this slope and average the two. So my average velocity is always going to be, from one point to another, the slope of the line that connects them. An instantaneous velocity would be, what is my velocity here, or what is my velocity here, or what is my velocity here. My velocity here is going to be the same as the velocity anywhere along this line. So what I would do is I would get the slope of this whole line, and that will give me the velocity at any point. So if the slope of this line were 4, then the velocity at that point is 4, the velocity at this point is 4, the velocity at this point is 4. Whatever it is all the way along, that's what it is at any individual point if this is a straight line. Now, I also could have a velocity time graph. So here, if I had velocity versus time, and I had a velocity time graph that looked like this, well, the slope of my velocity time graph is going to be my change in velocity over time, and I've already defined that as acceleration. So this slope is going to be the acceleration. But what's also interesting is that this area, the area underneath the curve here, which you could get by finding this triangle and this rectangle, this area is going to be velocity times time. Those are going to be the units, meters divided by seconds times seconds. And what is velocity times time? Well, in general sense, velocity times time will give me my displacement. Since v equals x over t, delta x over t, my average velocity is displacement over time. In this case, my displacement is going to be my velocity times time. So the area under a velocity time graph is always going to be my change in position. So the area is going to equal my change in position, which is good to know.